Every video about running AI at home opens the same way. You need the newest card, the most memory, the thing that costs as much as a used car, or do not even bother, and I get why people say it. The new hardware really is faster, and the demos look incredible. But I want to show you the other side of that, because the card I actually do my work on is a GTX 1080 Ti, and that card came out years ago. By the time you watch this, it is roughly 7 years old. It is not a secret tune build either. It is just an old card that I never replaced, and it still does real AI work for me every single day. So this is the honest version. What a 7-year-old card genuinely still does well, where it clearly falls down, and the practical tricks that make the difference. No hype, no pretending the old thing beats the new thing, just what actually happens when you stop waiting for the perfect upgrade and use what you already own. I think a lot of people stay frozen on the sidelines because they have convinced themselves they need to spend a fortune before they can even begin. And that is a shame, because the entry bar is far lower than the hype makes it look. You can learn an enormous amount and ship real work on hardware that the internet has already written off as obsolete. First, why I never upgraded. Let me be honest about how I got here, because it was not some clever plan. I bought this card a long time ago for gaming, long before I cared about any of this. Then I slowly started using it for AI work, and every time I thought about upgrading, the new cards were either sold out, wildly overpriced, or both, so I kept putting it off. And a funny thing happened. The longer I waited, the more I realized how much the old card was quietly handling without complaint. The upgrade I kept almost buying turned out to be a problem I did not actually have yet. That is really the whole theme of this video. The question is never whether a newer card is faster, because of course it is. The real question is whether the card you already own is good enough for the specific jobs you actually run, and for a surprising number of jobs, an old card absolutely is. Is a how-to-them, them. But the old card still does well, so let me start with the good news, because there is a lot of it. The first thing this card does genuinely well is video encoding. It has a dedicated chip on board for turning raw frames into a finished video file, and that little chip has barely aged at all. Every video on this channel gets its final encode done on this old card, and it is quick and clean and basically free in terms of effort. The second thing is local image generation. I generate images on this card all the time, and while it is not instant, it is completely usable. I queue up a batch, walk away, and come back to a folder full of results. The third thing is smaller language models. The chat-sized models that fit comfortably in this card's memory run perfectly well for summarizing, drafting, classifying, and answering everyday questions. And the fourth thing, which people always forget, is batch work. Anything I can line up and run overnight does not care even slightly that the card is old. It just grinds through the queue while I sleep, and the age of the hardware becomes completely irrelevant. Put those four together and it covers most of what I actually do in a week. Encoding, images, everyday language work, and big patient batches are not edge cases for me. They are the core of the job, and the old card handles all of them without me ever feeling held back. The demos that show off the newest hardware are almost always doing the one thing my card is worst at, the fast interactive stuff, and that single category is doing a lot of work to make old hardware look useless when it really is not, or it clearly falls down. Now I am not going to pretend this card is secretly a monster, because it is not, and you deserve the honest limits. The first place it falls down is the truly large language models. The biggest, smartest open models simply do not fit in this card's memory. Full stop. I cannot run them here, and no amount of clever tricks changes that wall. The second limit is more subtle. Newer cards support a fast, compact way of doing the math that AI models love, a low-precision number format that lets them run much quicker and fit more in memory. My old card does not have that hardware path at all, so it misses out on a big chunk of the speedups that newer cards get for free. And the third limit is just raw speed. For the exact same job that a new card finishes in seconds, my card often takes minutes. It gets there, and the result is identical, but it takes its time getting there. If your work depends on fast back and forth, that gap will absolutely frustrate you, and I would be lying if I said otherwise. And there is a quieter fourth limit worth naming. An old card draws a fair amount of power and runs warm, so if you are running long jobs, you will feel it in the room and a little in your electricity. It is not dramatic, but it is real, and a newer card often does the same work using less energy. None of these limits are deal breakers on their own. They just mark out the shape of the work this card is not the right tool for. And knowing that shape ahead of time saves you a lot of wasted frustration. The tricks that make it work. So how do I actually get useful work out of an aging card despite all that? It comes down to a handful of practical tricks, and none of them are fancy. The first is choosing a smaller, more efficient version of the number format the model uses. You can load a lot of models in a compressed 8-bit form that takes up far less memory and runs faster, with quality that is honestly close enough for most everyday tasks. That one choice alone makes models fit that otherwise would not. The second trick is right-sizing the model to the card instead of chasing the biggest one. I pick a model that comfortably fits in memory, with room to spare, rather than cramming in the largest thing that technically loads and then watching it crawl. A model that fits is faster and far more stable than a bigger model fighting for space. The third trick is offloading. When a model is a little too big, I can keep part of it on the card and let the rest sit in regular system memory. It runs slower that way, but slower and working beats faster and crashing every time. And the fourth trick is leaning hard on that dedicated encoding chip for all my video work, so the main part of the card stays free for the AI jobs that actually need it. A realistic sense of the speed. Let me give you a real feel for the speed, because numbers in isolation do not mean much. When I generate an image, I am usually waiting a short while per picture, not the instant result you see in the slickest demos. When I run a chat-sized model, the words come out at a steady readable pace, a bit slower than the fastest cloud services, but completely fine for thinking and drafting. And when I run a real batch job, the kind where I queue up a big pile of work, it is firmly in minutes, sometimes a lot of minutes. Here's the thing though, for batch work, that almost never matters. If I kick off a long job before bed and it is done when I wake up, I genuinely do not care whether it took 20 minutes or 2 hours. The wall clock time is irrelevant when nobody is sitting there waiting on it. The speed only stings when I am actively waiting on a single result, and the simple fix is to design my workflow so I am almost never doing that. I batch the slow things and reserve the fast back and forth for the cloud when I truly need it, so the trick is matching the job to the card. Once you see it that way, a lot of the frustration just disappears. A slow card is only slow if you insist on using it for the one thing it is worst at, which is fast interactive work, where you sit and wait. So I simply do not use it that way. I push every patient, repeatable, run it overnight kind of job onto the old card, where its speed truly does not matter, and I keep the impatient work somewhere else. The hardware did not get faster. I just stopped asking it to do the one job it is bad at, and suddenly it feels far more capable than its age suggests. That mindset shift is worth more than any single setting. So the obvious question is, if you are starting fresh right now, what should you actually get? And my honest answer is probably not a 7-year-old card like mine, because I got here by accident, not by choosing it as the best option today. If I were buying with real money right now, I would look hard at how much memory I am getting per dollar, because for AI work, memory is usually the wall you hit first, well before raw speed. I would also strongly prefer a newer card that has that fast compact number format built in, because that single feature unlocks a lot of models and a lot of speed that my old card simply cannot touch. I am not going to throw out specific model names or prices, because those change constantly, and I do not give buying advice on this channel. But the principle holds. Buy for memory first, prefer a modern card that supports the efficient math, and only then think about raw speed. The reason memory matters so much is simple. If a model does not fit, no amount of speed helps you because you cannot run it at all. But a model that fits and runs a little slowly is still completely usable. So the most expensive mistake I see is people paying for raw speed they will rarely use while skimping on the memory that decides what they can run in the first place. Get that ordering right and you will be happy with the card for years. When an old card is the smart move. That said, there is absolutely a case where an old card is the genuinely smart move, and I do not want to talk you out of it. If you already own one like I did, then the smartest thing you can possibly do is run it hard before you spend a single dollar on anything new. Find out what it actually can and cannot do for your real work. Instead of guessing, you might discover, like I did, that it covers far more than you expected and the upgrade can wait a long time. And if you are buying on a tight budget, a capable older card from the used market can be a very sensible entry point as long as you go in with clear eyes about the limits I described and you are not expecting it to run the very largest models. The worst move, honestly, is letting a perfectly good card sit idle while you wait to afford the perfect one. A card you actually use beats a better card you are still saving up for. The honest verdict. So here's my honest verdict after years of doing exactly this. A 7-year-old card is not a toy, and it is not a miracle either. It is a genuinely capable workhorse for video encoding, for local image generation, for smaller language models, and for any patient batch job you can run on a schedule. It clearly is not the tool for the very largest models or for fast interactive work where every second counts, and you should not pretend otherwise. But the lesson that actually matters here is bigger than one specific card. The newest hardware is not a requirement to start doing real AI work. It is an optimization you reach for once you genuinely understand what you need, and most people reach for it years too early. The card you already own is almost certainly more capable than the upgrade videos want you to believe. Use the thing you have, push it until it actually breaks for your real work, and let that be the moment you upgrade, not a feeling you got from a thumbnail. If you want more honest, hands-on breakdowns exactly like this one, with the real trade-offs and none of the hype, subscribe and follow along. Thanks for watching, and I will see you in the next one.